Today we want to talk about writing linear equations when they give you a word problem. So these are not your easy 30 because you have to take words and translate them into the equation, but they're really not that bad. So remember, when you write equations, you want to put it in y equals mx plus b. So if you know the slope and you know the y-intercept, you can just drop those two numbers in and voila, there's your equation. In a word problem though, the rate is your slope. So you're looking for things that talk about rates. And things that are rates are like $5 per hour, $5 every hour, $5 each hour. So when you look for the little words per, each, and every, those kind of tip you off that they're rates. And so rates are your slope, and that number goes here. The y-intercept is also your starting amount. So if they talk about there's a flat fee up front or at the beginning, which you have, that's your starting amount, and it becomes your y-intercept. And of course, you just drop those two numbers in, y equals in front and the x after that, and you've got it. Now, the slope number could be positive, it could be negative. If they talk about the situations being increasing, then it's going to be a positive slope number. If they talk about something decreasing, like maybe you have water in a pool and you're draining the pool, then the slope is going to be negative. So you just have to kind of read to see if it's an increasing situation or a decreasing situation to know whether that $5 is a plus 5 or a minus 5. All right, so here we go. Suppose that the water level of a river is 34 feet. So that's what it is right now. So that's going to be my starting amount. That's my y-intercept. And is receding. If it's receding, is the water rising or is the water coming down? Receding is coming down, so it's going to be a negative slope. And the rate that it's receding is 0.5 feet per day. So that number is my slope number. So down here where it says what's the slope, we're going to write 0.5. But is it a positive or a negative slope? It was receding, that means it's coming down. So this is going to be a negative 0.5. The y-intercept was the 34, right? So there's my 34. So when we write the equation, y equals slope number, negative 0.5, x goes after it, and then plus 34. And there's the equation. There's your slope number, and there's the y-intercept, and there's the equation of the situation. So all you got to do is pick out the slope and the y-intercept, and you can write a linear equation. Number 2, Seth's father is thinking of buying his son a 6-month movie pass for $40. So initially, how much is this pass going to cost before he ever goes to see a movie? It's going to cost him $40. With the pass, matinees are then going to cost him only $1. So and it don't say this, but each matinee is going to cost $1, or $1 per matinee, $1 for every matinee. So this is kind of like my slope number. So the money that he spends $40 to start with, and then every time he goes to a movie, is this the amount of money that he's spending over time going to keep increasing? Yes, so as time goes by, the amount of money that's being spent is increasing. So my slope is 1. It's going up, so it's a positive 1. $1 per movie, $1 each movie. So $1 times however many movies he's seen. And the initial amount was $40, so that's how much he started with, that he spent up front. So the equation, y equals, the slope number goes in front of the x. So since it's a 1, you don't have to write the 1, but it is there. And then plus 40. So y will find my total money that's being spent during the 6-month time period. All right, for babysitting, Nicole charges a flat fee of $3 plus $5 per hour. So as the night goes on and more time goes by, is the amount of money she's charging going up, or is the amount of money coming down? It's going up. So yes, this is going to be a positive slope. So this is $5 per hour is your slope. So that will be a positive 5. And then how much did she charge just for showing up? That's the initial amount. So there's my $3. I can find my paper. There we go. So 3. So what do you think the slope and the y-intercept represent? 5, the slope is my money per hour that she's making, and the flat fee that she charges up front is my y-intercept, right? So this is y equals 5x, because the slope goes in front of the x and the y-intercept goes on the end. Here we go. See, once you get the hang of this, they're not bad at all. So a plumber charges $25 for a service call, plus $50 per hour. Do you see that lovely rate right there? That's my slope. Write an equation for the total cost. And now they're, instead of using a y for the total, they're going to use c for the total. So just think about my c as being my y, and then every hour, how much is he going to spend every hour? $50 per hour, right? So $50 times 1 hour, $50 times 2 hours. So the hours are my x's. So h would be your x's. So just think about where the y and the x would go in the equation. Put the c where the y is, put the h where the x's are. So how much was the charge just to go out and visit the people before any time went by? Just to show up, it was $25, so that's my y-intercept. And then the rate was $50 per hour, so it's positive 50. Because as time goes by, the amount of money that he's going to bill is going to keep going up. So as time goes by, more and more hours, the total is going to go up. So y equals, oh, but then we're not doing y's, we're doing c's. So instead of y equals, it's c equals, that's my total cost, is equal to my slope number, 50x, but not x, we're using h, and then plus 25. Okay, normally it would be y equals 50x plus 25, but the c is my y for my total cost, and h is my x. There we go. Rufus collected 100 pounds of aluminum cans to recycle. He plans to collect an additional 25 pounds, so he's getting more pounds. So my totals are going up, so that's a positive. And it's 25 pounds each week, so that is my rate. How much did he start with? You're right, he started with 100 pounds. So 100 is my y-intercept, and he's going to collect 25 pounds per week. And it's a positive 25 because it's going to increase the amount of weight. They're using P for the total pounds. So total is always my y's. So this is my y, so P equals, and that means W weeks is 25 pounds per week, right? So 25 times X, 25 times 1, 25 times 2, 25 times 3. Instead of X, they were using the W's. So 25W, and what do we start with? Plus 100. There we go. So if you haven't tried to stop the video and do a few on your own, pause the video, try a few on your own, and see how you do. A canoe rental service charges $20 transportation fee and $30 an hour. So that's $30 each hour. That's my rate to rent a canoe. Write an equation for the cost y for renting a canoe for X hours. So as time is going to go by, am I going to be charged more and more money? Yes, so it is increasing. And then the 20 transportation fee was just the flat fee up front, just to show up with the canoe. So my slope is the 30 bucks per hour, and my y-intercept is $20. So they used y's and x's again, so y equals my total cost is equal to my slope, 30x, 30 times 1 hour, 30 times 2 hours, 30 times 3 hours, plus the initial 20 bucks at the very beginning, just to bring the canoe. A caterer charges $120 to cater a party for 15 people and $200 for 25 people. Assume the cost y is a linear function of the number of people x. So y is my total again. We're looking for the total cost. So it's still going to be y equals. And I'm going to have x for the number of people. Now this is an interesting one because they actually gave you two different rates. They gave you $120 per 15 people and $200 for 25 people. So if you set that rate up, that's $120 per 15 because my y's are the dollars and my people are my x's. And then the other one is $200 per 25 people. Now if you put both these fractions in the calculator, they both reduce down to 8. In other words, it's $8 per one person. So they gave you these two numbers, and when you reduce them down, they both equal $8 per person, or just $8. So my slope is $8. All right, and my y-intercept, if they didn't have any being catered, no people at all, then they're not going to charge anything. So my y-intercept on this one is a 0, which is a little different. We haven't had one like that. So y equals the slope, 8x, $8 times one person, $8 times two people, $8 times three people. And you can put the plus 0 here if you want to, but you generally wouldn't write it. You would look for that equation, y equals 8x in a multiple choice, okay? Because my y-intercept was a 0. So that was a little bit different one. An attorney charges a fixed fee of $250 for the initial meeting. Just to show up, he's going to charge you that. And $150 per hour. So $150 per hour after that. So there's my rate. So my slope is $150. Now, we want the total money that's being charged. So is the amount going to go up as time goes by? Yes. Every hour goes by, he's charging you more and more. So it is a positive 150. The y-intercept, how much did he charge just for showing up? 250. So write the equation. My total money is the slope, 150 times x, however many hours it is, plus the 250 just for showing up. There we go. Last one on this one. A water tank already contains 55 gallons of water when Baxter begins to fill it. So it already had some water in it and he's filling it, which means is it going up or going down? Again, another positive slope. Water flows into the tank at a rate of 8 gallons per minute. So there's my rate right there. So my slope is 8. And it's positive 8 because it's filling. And how much water was in there initially? 55 gallons. So how much gallons is in there altogether is equal to $8 per, this was minute, right? Yeah, per minute. So X's are my number of minutes. So 8 gallons per 1 minute, 8 gallons times 2 minutes, and so on, plus the initial 55 gallons at the beginning. There you go. You're now an expert at writing word problems from writing linear equations from word problems. Okay, next page. I just want to do this one real quick. These are the sequences. So it's been a while since we've done sequences. But in general, if you remember a sub 1, now sequences are things like 2, 4, 6, 8, dot, dot, dot. We're looking for a series of numbers, and they should have the same pattern every time. So this is add 2, add 2, add 2. So if you're adding or subtracting to get to the next number, it's an arithmetic pattern. If you're multiplying to get to the next number, then it's geometric. The arithmetic ones make straight lines, they are linear. The geometric ones where you multiply make exponentials. Just a little recap on that. Now, a sub 1 in these patterns is the first term. So in this one, a sub 1 is 2 because the first number is a 2. So a sub 1 is representing the first term. That's what that's telling you. Now, this is a lovely recursive formula. The only thing you can see in this formula is this minus 3. And minus 3 is the pattern that's happening, meaning you subtract 3 to get to the next one, subtract 3 to get to the next one. So a sub 1 is the first term, and the math pattern is subtract 3, subtract 3, subtract 3. The question is, what is the 6th term in the sequence? If you're just looking for the 5th or the 6th or the 7th term, just make a list and count over, right? What was the very first term? 4. So here's 4, comma. What math are we doing? Subtract 3. 4 minus 3 is 1. 1 minus 3, just put these in the calculator. 1 minus 3 is negative 2. Negative 2 minus 3 is negative 5. Negative 5 minus 3, and again, just put these in the calculator. Negative 8 minus 3, negative 11. Negative 11 minus 3 is negative 14. And we wanted the 6th one. Let's count. There's the first one. 1, 2, 3, 4, 5, 6. So negative 11 is the 6th one. Count carefully. And there it is right there. Notice that the 5th term and the 7th term were also over here as answers. So if you miscount, you're going to think you have it right. So count carefully. You're always going to start counting with the first term. First, second, third, fourth, fifth, sixth. And there's the 6th one. Okay. So sequences, they could be arithmetic, they could be geometric. Now, there are easy ways and hard ways to do this version of the sequences. They give you here the first 3 terms, and they just want to know which formula down here, which function represents that pattern. Now, the harder way to do it is to figure out what the pattern is and what the first term is, which is fairly easy on that, and figure out the pattern and then try to find the equation that matches that. The easier way to do these is literally just take this sequence and make it into a table. And then I can just put each of these equations in the calculator as y equals, right? This is my y equals, y equals, y equals. And where the ends are your x's. So y equals 8 plus parentheses x, subtract 1, close to parentheses 3, and just go look at the table. So here's my x's, here's my y's. This sequence are my y numbers. So this is my first y number, 11 is the second y number, 19 is the third y number. So my x numbers are 1 for the first term, 2 for the second term, 3 for the third term. So the x numbers are always just 1, 2, 3, 4 in order. And whatever the y numbers are, you start right here and just list them. So the first term is a 3, the second term is 11, the third term is a 19. So now that I've made my table, can I just go put these in the calculator, check their tables, and find the one that matches this table? Yes, and so that becomes a really easy thing to do. So pause the video, go put them in the calculator. The only thing I want to point out is these are exponents. So this is 8 parentheses 3 close to parentheses and then rooftop key, and raise this n minus 1 is the whole exponent up there. Okay, so these are big numbers. These are all big numbers. These are all big numbers. But this little n minus 1 is an exponent. So that rooftop key to put that in the calculator. And of course these over here are just your y equals. So which one matched it? Hopefully you paused the video and did it. It was C. Okay. Now this is one we did a long time ago, but we need to bring it back up because you never know when they're going to have one of these. It's about profit. So whenever you have a question that deals with profit, you got to know how to find profit. Profit is, let me get the equation over here for profit. Profit is money coming in minus expenses equals my profit. Okay, so if I'm selling cupcakes, I sell the cupcakes and I get money coming in. But I had to have ingredients to make those cupcakes, right? So the money that I received, I have to subtract out the expenses that I paid, and then what's left over is my profit. So money coming in minus expenses equals the profit. That's what you're looking for. So this one says, the kids in the neighborhood set up a lemonade stand to make money. The cost of ingredients was $11. So there's my cost of the ingredients. That's my expenses. The kids sold 52 cups of lemonade and made a profit of 26. So there's my profit. The cost, this was my expenses, right? 11 bucks is my expenses. And it says the profit is, let me say that again. The kids sold 52 cups of lemonade and made a profit of $26 if X represents the price of each cup of lemonade. Okay, so X is the amount of money I get. Maybe it's $1 a cup, or maybe it's $2 a cup. I don't know what the kids are charging for lemonade. Which equation could be used to find X? So all I have to do is write an equation about the situation that's true, and then I can use that to solve for X. Since it's profit, remember it's money coming in minus my expenses equals the $26 profit, right? That's my profit. So there's my equals 26. So how much money came in minus my expenses? What were the expenses in this? That was pretty straightforward. Wasn't it 11 bucks that I spent on cups and ingredients? So minus 11 equals 26. I just need the money coming in. How many cups did we sell? 52. And X is the price for each cup. So 52 times however much each cup costs. Maybe it's $52 times 1. Maybe each cup was $2, $52 times 2. I don't know what the price is, but it's 52 times X. So this is my money coming in. 52 cups at whatever the price of a single cup. So if I take that money coming in, subtract out my expenses, there's my profit. So which one matches that? Be sure you have the money coming in minus the expenses. So my expenses should always be a minus number, right? So there it is right there. Another sequence one. Okay, let's see what they're asking for in this one. What is the 7th term? If I'm just looking for the 5th or 6th or 7th term, should I just make a list? Yeah, go old school on these. You don't have to get all fancy with this stuff. Did they happen to tell me what the first term is? Yes, right there. A sub 1 is my first term, and it is -4, so -4 comma. Somewhere they have to tell me the math to do. Here's the formula that they give me. What's the only thing I can see in the formula? There's a +5. If it was a geometric one, you would see a parentheses with a 2 inside, as in a ×2 or a .2 or something where it's multiplication. But I'm just adding 5. So -4 plus 5 is 1. 1 plus 5, 6. 6 plus 5, 11. 11 plus 5, 16. 16 plus 5, 21. 21 plus 5, 26. And so on. Let's see, I wanted the 7th one, right? 1, 2, 3, 4, 5, 6, 7. So 26 is my 7th one, and there it is right there. Now notice 31 would have been the next one, and 21 was the one before, and they had 31 as the next one over here in case people miscounted. So count carefully. Oh, look, another sequence. It's a geometric. The first 3 terms are this, and we want to know which equation matches that sequence. So rather than trying to figure out the formulas by hand, all of these are in y equals format. Let's just make a table out of these 3 numbers, and then I can just go check the tables of each of these. So where do we put these numbers? Are they the x's or the y's? These are your y numbers. They're the pattern. So 48, 12, 3. So this was the first term. This is the second term. That's the third term. So x's are always just 1, 2, 3, 4 in order, however many numbers they give you. So now I put each of these in the calculator. Y equals, y equals, y equals, y equals. And this is 48 parentheses 1/4. This is a little exponent, so raise that with the rooftop key and -1. These are all big numbers. So instead of n's, though, what letter are you going to use? Yes, we use x there and an x here. This is another exponent, and that's another exponent. So you're just going to put each of these in the calculator and see which one matches that table. Okay, so go do that. Pause the video. Go put them in the calculator. This is the easier way to do it than try to figure out all the math. And there's that one that works. All right, 22. We are good at these. It's all math in the calculator, right? They're all numbers, no letters. So put that in the calculator, get a number, and then put each of these in the calculator, get a number, and see which one matches the right number. Now remember, do them all, because you could have 2 that have the same number that you're looking for, in which case you look for the one that has the smallest number inside. So if let's say these 2 had the right numbers, you would go with the square root of 5 because it's a smaller number inside, which is more simplified. We want the most simplified version. Okay, so if you put these in the calculator, there was only one that matched the number, and it was B. So it did match the exact same number as that one. I think it was 8.94427 or something like that. All right, now this is an interesting one. Normally when we factor things, we have 2 sets of factors being multiplied together, and if I multiply them together, they equal this lovely polynomial. It's, usually an r squared, an r, and then a number. However, so we could factor this stuff by hand, but with the graphing calculator, we don't have to factor it by hand. If I have both factors, I can simply put y equals in front of this one, look at my graph, put each one of these in at a time with y equals, and when you put both of them in, it will make the exact same graph if they're the same. So only one of these would make the exact same graph. However, this time they only gave me 1 set of factors instead of 2 set of factors. So instead of being able to make the whole thing, I still do the same thing though. I put y equals in front of this and go graph it. I put y equals in front of all these and go graph them. But instead of making a parabola when I put this one in, what it does is it makes a line that does this. It kind of does that thing. Okay, so this is the first one. I'm going to put y equals, and that would be x plus 2 in the calculator. All right, so that was A. It made that line there. What I'm looking for, since it's not making the same shape, is I'm looking for a line that goes through one of the two x-intercepts. So when I go to the next one and put in y equals r plus 1, or x plus 1, because we're going to use x's in the calculator, this one makes a line that goes right through, oops, I know that's not a very pretty line, pretend that's a straight line, it goes right through that x-intercept. So this is x plus 1, y equals x plus 1. All right. If you put in this one, r minus 2, it makes a line way down here, not through the x-intercepts, does it? This one did not go through an x-intercept, that one did not go through an x-intercept. And if I put in 2x, I think it does this, whoops, if I can get this better. I'm gonna hold this paper for just a second. Okay, so this is the last one, 2x, it makes this line here. It goes through the origin, but does not go through either the two x-intercepts. What's the only one that went through the x-intercept? This line, which was x plus 1. So this one is the factor that goes with that parabola. So when you're making, if you're expecting to make the same graph, but they make straight lines instead, you're looking for the line that goes through one of the x-intercepts. That will be one of the factors. So there's a cute little technique on that. So again, you don't have to go factor it all by hand. You can do it in the calculator and check your work that way. Now, if you want to factor by hand, you can, but check it with the calculator when you're done. Put that one in, put your answer in, make sure the line that you picked goes through the x-intercept of your parabola. All right, so next video, we'll give you the next 2 pages. It's a bunch of review stuff on the next 2 pages.